right, so let's take a look at our practice problems for the quiz today. For number 1, we always want to start with that same process that we talked about in the notes. Look and see if we can factor anything out. So I have two terms. They don't have anything in common. I can't factor anything out. There's nothing squared, so I'm not looking at a Pythagorean identity. So I'm going to change everything to sine and cosine. So for this beginning term, cosine is already cosine, so we're going to leave that alone. I am going to go ahead and put it over 1 though. And then that is times cotangent, which we know is the same thing as cosine x over sine x, plus, and then sine is already sine, so we leave that alone as well, but we do put it over 1. Now I can see that I have two fractions because that first two fractions multiplied together would just give me cosine squared x over sine x. Then I have plus sine x over 1. So two fractions added together, therefore I want to get a common denominator. So I'm going to multiply the second fraction by sine x over sine x. And then that will give me that common denominator of sine x. So then, if my denominator is just sine x, then let's look at our numerator. So we have the cosine squared x from the first term, then plus, and then when we multiplied the second fraction by sine x, that gave us sine squared x for the numerator of the second fraction. So then if we take a look at our numerator, we see that we have squareds, and we think, Pythagorean identity. And if you look at your identity sheet, you can see that cosine squared plus sine squared, or the other way around, equals 1. So if the numerator of our fraction just equals 1, and then our denominator is sine x, then we know that 1 over sine x is the same thing as cosecant x. And so that would be as simplified as we can possibly go. All right, let's take a look at number 2. So for number 2, I don't have anything I can factor out. In fact, they have already factored something out for us. They put it at the end instead of the beginning, but it's the same thing. And then if I look at this, I think, ooh, that could possibly be a Pythagorean identity. So take a look at your identity sheet, and you should see that that equals just sine squared x. So we have sine squared x times cosecant x, or squared x. And then we should recognize that cosecant is the reciprocal of sine. So that gives us sine squared x over 1 times cosecant squared x is the same thing as 1 over sine squared x. And so then since those fractions are multiplied, I can cancel the sine squared x on top and bottom, and then that simply leaves me with 1. And I don't get much simpler than that. So that one is done. All right, let's take a look at number 3. So for this one, I have a single fraction. I have cosine squared x over 1 plus sine x. So if I look at the bottom, that should stand out that that is almost a Pythagorean identity, and I can turn it into a Pythagorean identity by multiplying by its conjugate. So if I multiply 1 plus sine x times 1 minus sine x, then that will become a Pythagorean identity, which then will turn into a single term. And that's always helpful in simplifying when I have just a single term on the bottom. However, if I multiply by that conjugate on the bottom, I have to also multiply by that conjugate on the top. So then, if we take a look, we're going to go ahead and look at our denominator first, since that's kind of why we decided to do what we did. So if we multiply out those two conjugates together, I should get 1. Then my two middle terms should cancel out, negative sine x and positive sine x. And then I will have negative sine squared x. All right, that takes care of our denominator, which is going to be a Pythagorean identity, but we'll come back to that. And then, so for the top, we're just going to keep the cosine squared x times the 1 minus sine x. And so we're not going to multiply that out. We're going to leave it the way it is. And then we're hoping that something will cancel in a minute, which it will. So then for the moment, if I leave the numerator the way it is, and then I take my denominator, which we said would end up being a Pythagorean identity, look at your identity sheet and you will see that 1 minus sine squared x is the same thing as cosine squared x. All right, so then we can see, hey, I have a cosine squared x on both top and bottom. Therefore, those can cancel, which leaves me with just 1 minus sine x, and I'm not going to be able to get much simpler than that. So we are done. All right, for number 4. So I can see that I have two things that are divided. Now, I obviously can't factor anything out. I could possibly turn those into Pythagorean identities, but that looks more complicated. So I am going to look at changing both of those to sine and cosine. But before I do, I want to rewrite this so that when I change them to sine and cosine, which are going to end up being fractions, that it's a little bit more normal. So I'm going to say that this is cosecant squared x, and then this is going to be times 1 over cotangent x. Oops, squared x. So then I'm going to go ahead and put that cosecant squared x over 1. Because I've got this on top, cosecant squared x times 1 would give me cosecant squared x. And then on the bottom, 1 times cotangent squared x would give me cotangent squared x. So I've simply split it up into two fractions. So now, I can see that this could become tangent. 1 over cotangent is tangent. So I'm going to keep the cosecant squared x, but I'm not going to put it over 1 this time because I'm going to have times tangent squared x. And so since that's not a fraction anymore, I don't really want the cosecant to be either. Now I'm going to go ahead and change everything to sine and cosine. So my cosecant squared x will become 1 over sine squared x times tangent squared x is sine squared x over cosine squared x. And then we can see, okay, two fractions multiplied together. I have a sine squared on top and bottom, so they're going to cancel, which leaves me with 1 over cosine squared x. And we know that that is simply secant squared x. Alrighty. Now our last problem on the practice is to verify. We know it's verify because there's an equals. So when we have the verify, we know that we are only working on one side. I should not see any marks on the other side. So then I'm going to say I would probably simplify the left, but you could simplify the right as well. I would probably go with the left. Now, when I look at this, I see that I have two squared terms. I have sine squared and I have cosine squared. So I want to say that that's a Pythagorean identity. But if you look at your sheet, your Pythagorean identity is sine squared plus cosine squared. We have minus. So that actually is not a Pythagorean identity as much as it is tempting to make it one. But I can, however, take either one of these and I can replace them with something from my Pythagorean identity list. So then I am going to take the cosine squared and I'm going to change it. So I'm going to keep my sine squared beta and then I'm going to subtract. Now I'm going to have to subtract whatever cosine squared beta is. So according to your identity sheet, cosine squared beta is 1 minus sine squared beta. Now, you do have to be very careful. You've got to keep the minus and you have to have these parentheses because that minus is going to have to be distributed. So without those things, you're going to end up simplifying this incorrectly. So then, if I keep my sine squared beta and then I distribute my negative, then I have a -1 and I have a positive sine squared beta. So then, because both of our sine squareds are positive, they don't cancel, they actually combine to give us 2 sine squared beta. So those are both taken care of. And then I still have that -1. And what do you know? That's where I wanted to end up. Now you could do the other side by doing something very similar. So that side would be a little bit more complicated because you've got to know that you would have to break up the 2 sine squared beta. And that's not something that most of us are going to think to do, but it can be done. So if I took the other side and I wanted to simplify it, I could say, okay, I have 2 sine squared beta, so I know that that's the same thing as a sine squared beta plus another sine squared beta. Then I have my -1. Then I would have to think, okay, sine squared beta -1, that's almost a Pythagorean identity, but the signs are wrong. So if I had a negative sine squared beta and I had a positive 1, then that would be a Pythagorean identity. So what I can do then is I can take my sine squared beta in the beginning and leave it alone, but then I can factor out a -1 from these 2 terms right here. So if I factor out a -1, and I'm going to rearrange as I do it, so if I factor a -1 out of the -1, then that leaves me with a +1. And then if I factor -1 out of my positive sine squared beta, that leaves me with a negative sine squared beta. And so then that is a Pythagorean identity. So I've got sine squared beta minus, and then this entire thing becomes cosine squared beta. So technically, I've got -1 times cosine squared beta, but I don't really need the 1. -1 times cosine squared beta is just going to be negative cosine squared beta. So we have sine squared beta minus cosine squared beta, and that gets us to the other side. So I personally prefer this way, but it can be done the other way as well. All right, so those are your practice problems. Remember that for verify, you will work on one side of the equation only. You will not do any marks on the other side. You're simply taking one side and working it until it becomes what you have on the other side. All right, so you are going to put that away now and make sure you have your identity sheet, and then go ahead and get your quiz done. Good luck.